Hey friends, in this video I'm sharing 3 real coding mistakes I made in production mobile apps. Mistakes that either slowed the app down, broke features or made maintenance a total nightmare. I'll walk you through what went wrong, how it affected real users, some illustrative code samples since I can't share the original code base, and most importantly, what I learned so you don't make the same mistakes. Let's jump into the first one. So this happened while I was building an e-commerce app. I had a product list screen that fetched data, processed filters, and updated the UI all in one big synchronous function. Yeah, I know. That was years back, so please go easy on me. So I had a simple function here that was calling two other functions and then initializing it to this variables. And at the end, we have a UI logic that's waiting to update the UI. So this innocent looking function was blocking this main thread, the UI thread, making the app freeze for 3 to 5 seconds, especially on older Android phones. Imagine that. Just to recap, the UI thread is responsible for drawing widgets, responding to gestures, running the build function method and the init state. So when you block it, your app feels very frozen. So we got slammed with 1-star reviews like the app freezes every time I open the product screen, laggy and slow, uninstalling immediately. Not the kind of feedback you want to land on your boss's desk. So some of the things I learned is never to run heavy operations on the UI thread like this too. And smooth performance is equal to professionalism or a professional feel. So it and also if it lags or it feels broken, regardless how beautiful your UI looks, you're already messed up. So how did I fix this? So I refactored the code to use Flutter's compute and async tasks. So all we had to do is make this function as async and make this called asynchronous. So we await fetch from database and also use the compute to do that. So heavy work runs in a separate isolate. Compute is another way of saying that's version of background threads. So when you do this, the UI thread stays smooth and responsive. It's not doesn't have to lag and wait for all this to be done. Okay. So think of the UI thread as a chef in a small kitchen. If someone asks them to chop 500 onions, they hand it off to an assistant. In our case, it's the compute method so that they can still continue cooking. So we still get to have a UI that's responsive while these other functions are being processed. I hope it makes sense. So the takeout here was that it's very important to profile your app, just like taking your car for a checkup. Before you take it to production, it's important to profile your app. And also, code that works isn't always code that performs. So it might work, but it's not performing as it should. And also, using compute, it's also good to use compute, the compute method, or isolate for CPU heavy tasks. So if you want a guide on how to profile a Flutter app properly, please drop a comment below. Now this one hit hard. So I was building a shuttle booking app where users could book a bus, pick a seat, all in real time. So what went wrong? So I assumed users will always have internet, I know. So I made API calls without considering offline scenarios, as you can see in my function. So I went straight to use the HTTP package to send a request and expecting a response and setting it in a UI, which obviously is a problem. So what happened is one tester opened the app in an underground parking lot and it crashed immediately. So the feedback came in like crashes when offline, or somebody else said no fallback, no cache. It's so useless when traveling. Man. So one of the things I learned from just this simple function is that offline fast design is very essential and it's not optional anymore. Also, even minimal caching can improve user experience dramatically. So, if you find there's a scenario where you can perform caching in your app, so to create that good experience for your users, go ahead. And also, don't assume perfect network condition, which is obvious right now because everything runs on internet. So it's important to test in airplane mode as a developer. Once you're done with it, executing everything, just turn your phone into airplane mode and run that app and see how it will work. So how did I fix it? So using the same function, I decided to use a simple try and catch. Imagine that. How powerful this block is when you don't use it. That's when you realize how powerful it is. So I use the try and catch to save the user's information or save some cached routes, as you can see, and I use shared preference for that. So shared preference is a local storage that you can use to store cache. In my case, is cached root data, so that in case there is no internet connection, there's a failure, it will proceed to go and get whatever has been cached in the shared preference and set it in our UI. So the user will never feel like there's no fallback and get stranded. If you're interested in learning about shared preference, I think I do have a video on that. I'll link it. So one of the things to look at when in such a scenario is you should always test, as I said again, your app in airplane mode. Don't assume. So finish your whole design and development implementation, then try and put it on airplane mode and see does everything run as it should. Another thing is caching non-sensitive data locally is also efficient. So if it's sensitive, make sure it's encrypted or using a secure storage. But it's good to also consider is there data that a user might need and may not have access to it remotely or externally, that I can set it locally for them to access easily. And lastly, obviously, it's our try and catch block. It's very important to be able to catch any errors that we may have and not leave. If we don't catch it, we leave our users stranded on the UI. So this one's a classic. I was working on a mobile banking app and I created a God class. That's a single class that handles the UI logic, the business logic, the API calls, the navigation, the state management, everything in one file. This was way before clean architecture became mainstream. So it was about speed over quality and it backfired, obviously. So this is the kind of class I had. There was UI logic, the API, there is the business logic, we have the state management, we have the navigation scenario. Damn. So you can see how much it was. So the class was so impossible to test because there was so much put in one class and every feature was tightly coupled. So fixing one bug risked introducing five more, which actually happened. And the most unfortunate thing for a developer is that in my case, no one else on the team wanted to touch that code, which meant even on sick days, I was still on the hook. I had to like work on it because I was the only one. I was the creator of the mess. I had to manage it. So some of the things I learned, which is way back, is that when everything is coupled together, everything breaks together. Even the slightest code you might think that it's simple that might not affect, when you put it in such logic, is something that's bound to break. Another thing, obviously, is that clean and modular architecture is worth the upfront effort, and separation of concerns makes life easier for everyone, and that's so true. You really need to think about yourself when it comes to like maintenance of the code. When it comes to testing, will it be easier for you to manage or to maintain your code even after production? So this one really caught me hard and core. And what I did is I decided that one morning that I would get I'll get into the office very early clean my glasses, plug in my AirPods, and refactor the whole code because this was a mess that was around the whole project, not just what I've shared. And I refactored the code for 5 straight hours. I can assure you by lunchtime, I had versioned out that monster in separate layers. And none of the examples are this. Anything that revolved around authentication, I gave it a separate service class. Anything that revolved around transactions, I gave it its own separate class involving caching. I separated the models in their own separate screens, and I just broke down things into modular versions to make it and created separate layers for every type of logic or type of implementation that I had. So, one of the things obviously that we can take out from this is that please avoid God classes like the plague. I know you might feel like, let me just code everything quickly and then later, the word later, I'm going to now like break it down, put them in functions, put them in different service classes. That later might not happen. You might end up executing, and then sometimes as developers, we find that satisfaction of everything is working. Remember, just because it's working does not mean it's performing. We actually realize something is performing when it's held by a tester or a user. But the unfortunate thing of like telling yourself that you'll come back and change is that sometimes there's not that time. That time is not there. So you end up sticking with God classes just because you didn't structure or create a form of architecture of how you're going to organize your code. Another thing is following the solid principles and clean architecture, which is a vibe currently. Even Flutter have their own Flutter architecture that they have shared on the official documentation on how you can design your Flutter project. If your class has like more than 300 lines, that's a big red flag. You should like set for yourself rules that if a certain class or a file has like more than 300 lines, that's very dangerous. There's something that's just off. Great. So with that, let's recap the three big mistakes. So the first one was that they're blocking the UI thread. Always offload heavy work using isolates or async calls. That's the secret. Then there was no offline handling. So assume the worst network conditions and plan accordingly. And lastly, keep your code modular, testable, and clean. If you've made any of these mistakes, don't worry, we've all been there. The key is to learn fast and improve. If you want me to deep dive into topics like profiling performance, offline fast architecture, or clean code structure, drop a comment below. Like, comment, and subscribe if this helps you. Until then, see you on the next one.